Howdy! Welcome to Aspire Mountain Academy. I'm Professor Curtis, your instructor for this course in Introductory Statistics. In less than 10 minutes, this video demonstrates how to use z-score tables to find probabilities for a standard normal distribution. Let's get started. So a z-score table is basically tabulated areas underneath the curve for the standard normal distribution. And it's for this reason that the z-score table is also called a standard normal distribution. To calculate the area under the curve for a standard normal distribution, or any normal distribution for that matter, requires the use of integral calculus. That's well beyond the scope for this present course. Those who actually can do the calculus in solving probability problems involving a standard normal distribution, they find it tedious to have to calculate the area under the curve every time they need a probability. So what they've done is they've actually calculated that area for standard sets of z-scores and put them into a table. So we don't need to go through the calculus every time we need to calculate a probability. We just look it up on the table. So what you're seeing here on the screen now is one portion of a z-score table. Let me demonstrate how to use the z-score table. One of the things that you need to keep in mind with the z-score table is that the z-scores are actually split in between the axis on the side and the axis on the top. So you see parts of the z-score here on the side and another part of the z-score here on the top. In all cases, the area that we're calculating with the z-score table is typically to the left of the z-score. This is the convention that's used in crafting z-score tables. Now, if that's not the case, you should see some notation towards the top of the table that says that you're going to be calculating the area to the right of the z-score. But typically, especially where you don't see any type of notation that tells you which side of the z-score the area under the curve represents, you're going to it's just assume that's the convention, that we're calculating the area to the left of that z-score. So as I said, the z-scores are listed in two parts. One part's along the left and the other's along the top. So let me show you how this works. Let's find the area to the left of z-score of 0.64. So first we have to recognize 0.64 has two parts to it. I can take 0.6 and add 0.04, and that gives me 0.64. So I can separate out 0.64 into these two parts. Then I'm going to take that first part, and that's identified with the area, the z-scores that you see towards the left of the table. So I'm going to find the row that's associated with z equals 0.6. That's going to be this row right here. Next, I'm going to identify the column associated with the second part. So z equals 0.04, and that's going to be this column that you see right here. So I've got my row and I've got my column. Now I'm going to look for the intersection of those two, and that value that's located at that intersection is the area to the left of our z-score 0.64. That's this value right here, 0.7389. This is the same as the probability that our z-score is less than 0.64. Because remember, it's the area to the left of that z-score that's underneath the curve. So if we have a standard normal distribution, the z-score bounds the area under the curve. We want the area to the left because that's what's being calculated with the z-score table, the area to the left. And this number here corresponds to that shaded region to the left. Underneath the curve, it's bounded by that z-score. So we can actually run this same procedure in reverse. If we've got a probability, we can use it to find the z-score. So if I know my probability is 0.7389, I simply find that value here in the table and then backtrack. So here the column heading 0.04, here's this row heading 0.6. I'm going to add the 0.6 to the 0.04, and that gives me my original z-score of z equals 0.64. So it can go either way. We can start with the z-score and go to the probability, or we can start with the probability and find the z-score. There's some considerations that we need to keep in mind when using the z-score table. First, using z-score tables is appropriate only when you have a standard normal distribution. So remember what we talked about in the previous mini lecture. In order to have a standard normal distribution, you must have a mean value of 0 and a standard deviation of 1. So you have to meet the requirements for a standard normal distribution in order to use the z-score table. Second, the table usually takes up 2 pages. So there's usually what's called a negative half and a positive half. The negative half being those values that are to the left of 50%, because 50% is right there in the middle, so to the left of that mean value. And then the positive half is to the right of the mean value. So there's one for negative z-scores, which are on the left of the mean, one for positive z-scores, which are on the right of the mean. Now each value in the table body is a commutative area from the left up to the boundary specified by the given z-score. So sometimes you'll be working with graphs. Please don't confuse z-scores with areas, okay? They are not the same animal. Z-scores are simply the number of standard deviations that a random variable is from the mean. So that's going to be the distance along the horizontal axis for your standard normal distribution. So the values you see along that horizontal axis for the standard normal distribution are your z-scores. The area is the region that you're shading underneath the density curve that's correlated with the probability that you're interested in. So the z-score and the area, they are related, but they're not the same thing. You also want to remember that the part of the z-score denoting hundredths is found across the top. So the tenths is usually found along the side. The hundredths is found across the top. Your z-score is split into 2 parts, one part along the side, the other part along the top. Let's look at an example problem really quick to demonstrate how to use the z-score table. So we have a bone mineral density test that can help identify the presence of osteoporosis. And the result of the test is commonly reported as a z-score. So we're asked to find the probability that the bone density test reading for a randomly selected adult is less than 0.46. Well, first we get our z-score table out, right? So we want the reading to be less than 0.46. So first thing we have to do is recognize that our z-score table has the z-score in 2 parts. So we're going to separate out the 0.46 into 2 parts, 0.4 and 0.06. Then we're going to find the row for the first part, the 0.4, and that's going to be listed here. And then we find the column for the second part. So you see that there with the blue. And the intersection of that row and column of interest gives us the area to the left underneath that density curve. That's going to be the same as our probability because we want the probability that we're less than that z-score of 0.46. So 0.6772 is going to be the probability that a randomly selected adult has a bone density test reading of less than 0.46. Now, what if we wanted the area to the right? What if we wanted the probability that you were greater than 0.46? Well, remember, the area under the density curve is equal to 1. And so, therefore, we could just subtract this probability from our z-score table from 1 to get the area to the right. And that's how we calculate that. We just use the complement. So we subtract it from 1, and there's our probability. And that brings us to the end of this mini lecture. I hope you found it helpful. You can find more mini lectures for this and other courses at AspireMountainAcademy.com. Thanks for watching. I'll see you in the next video.